Ready for coming out, hearing my session on open automation and the future of DevSecOps and how we talk about how flow metrics actually go into driving those DevSecOps reports for a lot of our customers. So I like to joke with everybody, so I know a lot of people have been hearing about Gen AI this week and all these other great things, so I tell everybody this is my Tinder profile. So I ended up going to a session where they were doing sort of like it was an executive briefing, and they had this little photo booth, and you could come in, and I did not like any of the photos, so I asked Midjourney to make me look like a handsome 40-year-old with a light tan, and this is what I got. So in today's session, I want to talk about things around simplifying the software supply chain, events and how those events flow through the software supply chain, how events and tasks are related, and then measuring tasks and then establishing actionable tasks and metrics around those. So this is really crazy because I've been speaking here at All Things Open for, this is now my 9th year. I actually think I used this slide in my very first talk, and it's amazing how this slide has not needed to change. I think the only thing I've added in here is the security piece in the middle. But when we think about the software supply chain, we think about having software factories and then also software logistics. And these are sort of the different activities that we have on each side of both of those. And so when we think about the things that we need to automate and the things that we want to try to get better at, when I go around with the GitLab sales team, one of the things I have to explain to them is, as a VP of engineering, a lot of times that time spent on hiring. So we have hiring of resources, that's where their budget goes, it's about people, and then we try to hire the best people that we can. And then on the operations side, they spend their budgets on tooling. Because in a lot of very large organizations, I might have 100 engineers to one operations person. And in a lot of companies, they actually try to grow that ratio. So they would like to actually have 200 engineers to one operations person. So the budgets that are spent on tooling on the operations side are to amplify the skill sets to build automation around the tasks that are at hand. Now, part of some of the things that are really scary to a lot of our customers right now is if I take the software factory side where the engineers are now using generative AI to go ahead and build all of this new code, the blocker is going to still be on the operations side. Because a lot of our customers still struggle with automating a lot of the things on the right-hand side. They have a few teams that do it really well. They try to build patterns. They try to build best practices. But then you always have those sort of snowflakes inside the organization, and then they try to give control over to the engineering teams, let them go do it, and then they start to find out that they pause or stop certain parts of their pipelines, and they're building artifacts that have not been scanned, and then they have vulnerable code that's sitting in production. And then everybody gets upset, and then they decide to lock everything down again. So this is one of my favorite slides when I give this talk is, I am a huge Oreo fan. Any other Oreo fans in here? All right. So what's amazing to me, now every time I've given this talk, I've yet to have anybody raise their hand. Anybody ever buy a pack of Oreos, and inside that pack of Oreos have a rogue Oreo? Meaning you go buy a double stuff and it ends up being the peanut butter filling or the chocolate filling. Anybody ever have that happen to them? Nobody. It's amazing. Every time I've given this talk, never had anybody get a rogue Oreo. Now, can we say that same thing for our operations teams? Ever have a rogue artifact all of a sudden end up making it into production? So we have a lot that we can learn from our Oreo manufacturers and how we're able to reproduce things in a very consistent, packaged manner where we don't have rogue Oreos sitting out in our environments. I used to work here in Raleigh. One of the companies I worked for was Railink. Is anybody here from Railink? Anybody? So we got somebody from Railink back there also. So For those of you that don't know what Rail-Link is sort of the enterprise-to-enterprise hub between all of the railroads all over the country. So whenever a rail car goes from BNSF to Canadian Pacific and it gets interchanged and it's got to move the cars in between them, we have these consists. We have these things that are organized together. And so this is the logistics side. So I've always been curious that I would love to go to a Nabisco plant and say, here is my 1 pack of Oreos that I picked up at Harris Teeter. How did that actually get grouped together, put into a truck? How did it end up getting to my grocery store? And there, again, so many things that we can learn. So there's this concept around logistics and transportation called multimodal. So anybody here ever order anything? There's this new company online. I believe their name's Amazon. Anybody order anything from Amazon? So it always shocks me how I can go ahead and say, oh, I could have it tonight at 6, or I could choose to have it tomorrow by 7 o'clock, or I could save some money and have it arrive 2 days from now, which is my Prime Day. It amazes me that they can choose all these and how they are able to shift back and forth. We have large enterprises that have no idea what their delivery date is for a release that's being packaged right now. They can't tell you when it's going to go live. And these are things that we need to get better at. And the way that we do that is we could learn, again, from the logistics company about, again, automation. How do we automate these capabilities? We also have things that come from these industries that a lot of people don't even realize. I remember having a conversation with an executive, and we were going through, we had a change review board. Anybody ever be in a change review board? Okay. Got quite a few of those, right? The wonderful Excel spreadsheets with all the tasks we need to do to roll out a production, and then we have both the successful as well as the unsuccessful and what the rollout is, and I go all the way back to change review boards when we had to carry pagers, and if you were one of the people in those, that your pager number was there and you would get notified. Well, these things around change review boards, somebody was telling me, oh yeah, this is a technical term. I've never seen these before. This is new. I sat there, I said, have you ever read the book around the Toyota manufacturing process? I'm like, no. I said, you need to read that book because that's where change review boards came from. And he was like, what are you talking about? I said, yeah, whenever somebody at Toyota, when they're going through the assembly line and whenever there was an exception, they had to document it. So they would go over and they had an exception board and they would write down what they tried to do, what didn't work, and then they would document it so that way it would get back up to senior executive management so that way they could go ahead and fix upstream inside the factory so the next time it came back to that person, they would never run into that issue again. I said, does that sound familiar in your change review board? Yep, that's exactly what we're trying to do. So a lot of these things we can learn in this slide. You've got somebody who's holding a manifest. Anybody here deploying to Kubernetes? Okay. What do we call those files that we're getting ready to deploy with? It's called a manifest. Why is it called a manifest? Because I am targeting, this is what my target state is supposed to be. That target state in that manifest is the same thing. I'm expecting for there to be 110 containers on this boat. Well, if you go through and you count, instead of having 110, what if there's 112? In the IT world, we call that an exception. Guess what they call it? It's an exception. And then what we have to do is we got to figure out why we have an exception. We got to do root cause analysis. Why do I have 112 containers on a boat that's only supposed to have 110? So all these things are real life things that we could be going out in the industry and learning how do they automate these things and how can we apply that to our own lives. So normally, when we think about the software development lifecycle, I have to break it down for a lot of executives. I love working with executives. So many of them have come from an IT background, but they, over time, have started to lose sort of touch into what's actually going on. Like I try to walk them through a DevOps lifecycle, and they go blank. So I break it up into 3 categories, 3 buckets. So we have process management, developer experience, and change management. So process management is my agile, my waterfall, my scrums, my stand-ups. All of those things all go into process management. And then we have developer experience. So that's where our developers go. They've got where they collaborate with other developers. It's where they get their feedback from their other tools. And then we have change management. And this is, well, anything that I'm about to do is a change. So I make a few lines of code change to my application, that's a change event. So you can think of a pull request in GitHub, that's a change request. A merge request in GitLab, that's a change request. And then you have a series of change events that all equate to how do I validate that particular change. And the way that we do that today is through CI/CD. And so through a pipeline, we have a series of other tools that all stitch into that CI/CD process. And in every organization that I talk to, that automation from process management through change management always goes from left to right. And we're starting to see a shift. And part of the problem with this process is the developers, like this is, I go in and I'm in Jira and I start working on a ticket and I go ahead and my branch gets merged. Well, as soon as my branch gets merged and it goes into a release branch, it goes back into main, whatever that process looks like, the developer goes, I'm quote unquote done. I can go on to the next task. Well, we haven't even released it yet. It hasn't gone out in production. Well, I can't work that way because I'm in a sprint and I've got 20 other tickets I need to work on. And most likely I'm not going to even release this until the end of the sprint or maybe even after that sprint. So we now have this broken process where change management is still in flight, but process management and developer experience, they've already closed the ticket out and they've gone on to the next step. So when we go through this process, we have a series of events that take place. So when we go through and I'm in my different tools and I have an event that gets created, so I have an issue created event, an issue closed event. Through the developer experience, I've got a pre-receive hook, I've got a post-receive hook, I've got a pre-commit hook. I've got all of these different events that are taking place. I've got a merge request is open. I've got a label changed. Then in change management, I've got the same thing. I've got a service ticket open, a service ticket closed, a service ticket changed. And then in CI/CD, we have a whole other set of events. So I've got a pipeline created, and I've got a pipeline completed. Now, part of the challenge of this is all of these events are asynchronous. So they're fire and forget. So in CI/CD, a lot of times, we get a binary response. So we get a success or fail as part of that pipeline. And a lot of times in tools where it's going to be a very long-running process, like if there's a manual step, what I end up doing is I end up getting a status spec of a 200 because I've connected to the tool and the tool has said, yes, I'm letting you know I'm kicking off a pipeline that's just going to respond back with a 200, which is a quote-unquote status success. But then the pipeline runs for 2 hours and an hour and a half into that process, it fails. Well, I don't know that it failed. I have to context switch. I've got to go to the tool. I might get an email notification, something else that tells me your pipeline failed. Here's where it failed. You have to go log into that tool. You got to figure out what happened. And some of our most regulated industry customers, sometimes they don't even have access to those tools. They actually need to open up a support ticket, get somebody to go pull the logs, send them the logs in an email, and try to troubleshoot without having access to the tools directly. So when we do this, we end up creating silos of events, and these events are not correlated. And as we go through this process, all of these events, we can't track an event from step 1 to step 2. This is where automation could really help us. When I look at other industries, when I'm looking at that cookie type manufacturing process, there's a lot of things that we are doing throughout that process to do quality control throughout that automation. And that's why I'm not ending up with a bad cookie in my double stuffed package. There's somebody who sees a peanut butter coming along and they pull it off to the side. They want to make sure that the automation that they have, that there's people throughout that process that are validating the change. Now, as we think about this event storage, we today have so many different tools in our tool chain. And all of these tools are creating events. So when we have these events, we can't correlate them to anything that allows us to be able to say, what was the root cause of a particular failure? It's very difficult to be able to walk back across events. So what do? We try to shove these into our Datadogs, into our Splunks. We send all of the events there, and then we try to munge them all together and try to make them work. but then I lose the context for where the event or why the event actually occurred in the first place. Well, did this come out of my developer experience, part of the tool chain? Did it come out of my pipeline? Did it come out of the change management process? So this is a huge challenge with a lot of our customers. So here we've got this huge web of all these different events. None of them are being correlated. So how can we try to fix how we go down this path? This is not it, okay? So I used to work at GitHub. I'm now at GitLab. Every time that we have people that are trying to use webhooks, they struggle. Number one, if the targeted tool that the webhook is supposed to go to is down, we don't have retries in our webhooks. It just falls to the ground. It's like a dead letter queue in a queuing system. And when that happens, all of that data that we're trying to correlate, we have a missing set of data. When we have a missing set of data, anybody in here a data engineer? Anybody a data engineer? So when we have missing data, what's that data called? It's corrupt. Now, if you went to your executives and said, oh, by the way, I'm just letting you know that here's our entire development flow, and here's where our best teams are, but I'm letting you know that 38% of all this data is corrupt. Can I trust that data? Can I know which teams are actually the ones that need more training, that need more tools, need better automation? I can't do it. So we need a better path. So when we look at event systems and the way that event systems are designed, there's this thing called flow architectures. Has anybody read the flow architectures book? If you haven't read it, I highly recommend it. It is a very good book. Talks about eventing systems, different types of eventing systems, how you build HADR into these eventing systems. And when we think about this, normally the way that we think about events is there's an event with a task. Now, how many people here have kids? Right? Great. So for those of you that have kids, we call these chores, right? So dirty room, the event, task, clean the room, right? When that task isn't met, then there's repercussions. I have a retry event. And that retry, go back to the kids. I need you to clean your room. Let me just finish this game. Oh, wait, friend just called. Oh, you know what, I'm gonna go out for a little bit. I'll do it when I get back. But we need to get that task complete. So having this one-to-one mapping doesn't always work. So then we end up in the spouse scenario. Because this is what I get. I get one event and it always maps to multiple tasks. So, hey, by the way, you're home for the weekend. Here are your 18 tasks I need you to do this weekend. So when we have this type of scenario and we've got multiple tasks, these events and task correlations, this actually becomes really hard to do from an automation perspective. So every time I see people that are building pipelines in whatever tool of choice you have, a lot of times we build singular paths. So we go job 1 to job 2 to job 3 to job 4. And we get really nervous to parallelize any of the particular tasks. Because in this scenario, I can retry the task before I go on to the next one to ensure, again, that the data for that task is good. If I go down this path and task 1 succeeds but task 2 fails, what does my retry look like? Do I need to retry the first task as well? How do I just retry the one that's in between? Well, this goes into how you define your orchestration engine. So when I was at GitHub and we were working on GitHub Actions, I learned very quickly that CI is really simple when you think about how it's built. So you need an orchestration engine, you need a workflow engine, and you need a job engine. So when you're going out there and you're looking at those things, a lot of tools that are out there have okay workflow engines, depending on what language. Do you want to write it in Groovy? Do you want to do it in YAML? Do you want to do it in some other language? And then you have okay job engines. We've all pretty much figured out now that the best way to run a CI job is to make it ephemeral, run it in Docker, destroy it, then recreate on the next build. That way we can make sure that we don't have bad caches and things like that. The key part is the orchestration engine. Most of the CI tools that exist come from an age where orchestration engines were single-threaded. Because what happened is through this entire event process, we wanted things to be serial. Anybody here who is very interested in how you do orchestration properly, go right outside and go talk to the folks at Temporal. I have been a huge fan of the work that Uber did, and what was the underlying technology that Temporal came from. It is Cadence, thank you. I have been a huge fan of Cadence forever. GitHub Actions was originally supposed to be on Cadence before Microsoft acquired them. We were using Platform 9, Cadence, and a few other tools. The orchestration engine was phenomenal. This type of scenario is, it's like, yeah, throw something harder at me. So when you go ahead and look at things where you have a really strong orchestration engine, then what we end up with is usually it's an OK workflow engine and an OK job engine. So how do we get to a point that I can get really good at all three of those, plus being able to handle every event that's being thrown at me? So when we go ahead and we start to build out that model, now we're able to have streaming workflows. And those streaming workflows are not only having to go one direction, but now they can be bi-directional. So a task can come back and respond back to an event, so now I can build logic into my automation. So if this task succeeds, then I want you to go run task 2. This becomes very intriguing to a lot of customers because they have situations throughout their entire process, their DevOps lifecycle, where they want to have conditionals. So what a lot of our customers right now is, I did some analysis with about 5 of our customers. And when they start really automating a lot of this process, their commits inside their cloud utilization goes up exponentially. But unfortunately, as that goes up exponentially, the automation underneath it, that price goes up exponentially as well. And a lot of times we end up building things that we're never even going to send off into production. So if I can have this kind of model, imagine me being able to go off and say, okay, on this next code change, I'm going to go ahead and run my security scanner, and my SAS scanner comes back and tells me, you've got 3 criticals. That violates our policy for production, so I'm not even going to go do a build. Why should I go build it? I've got 3 criticals. There's no way that artifact's ever going to get into production. That violates our policy. So now if I can start to build conditionals, I can now optimize the workflows to allow me in the automation steps to say, when I meet certain policies, I can go on to the next step in my process. This is where all of our customers want to get to. They want to get to a point from issue to production that they can have a series of incremental steps to be able to say what's allowed, what's not allowed, and being able to determine where they're actually going to spend their compute resources. So when we think about these tasks have to become transactional. I can't tell you how many people I've gone in, yeah, you know what, we've tried rerunning this pipeline 3 times because, you know, we have flaky tasks, we've got flaky other things, and hey, sometimes when we get to the 3rd rerun of the pipeline, we get lucky and it just works. Now, imagine if you're going to the bank and you're going in to take some money out, and you're standing there with a teller and you're handing them, hey, I want to cash this check for $100. And they go into their system, and their system gets to step 2, and it fails. And they go, I'm sorry, I can't give you your money. Well, yeah, what? I know my money's in the bank. It's right there. It's right behind you. There's a little drawer. Just open it up. Give me my $100. Well, let me try rerunning the process. Okay, now I got to step 5. Okay, but it still failed. Could you imagine what that customer experience is? You'd probably be like, I'm going to another bank. So when we think about this, we don't think about the user experience around the automation that we put in flight for our customers. And a lot of times, I have to have very long, meaningful conversations with platform engineering teams because they have ended up with automation with their pipelines. And we go through, and I mean, sometimes I feel like I'm in I'm a psychologist sitting in an office with them because they just want to break down in tears. You don't understand, Leon. Step 3 was written by a developer 10 years ago, and we're just really scared if we turn it off. We don't know what's going to happen. Well, have you tried turning it off? No. The risk is too high. I'll tell you what, let's just try it. Let's see what happens if we turn off step 3. Oh, it worked. Great. Okay, so you go through these automations, and we end up inheriting, there's this process on the development side that we do refactoring. We do quality. We go back through over time, and we prune, and we make things better. I feel like on the platform engineering side, when we build these pipelines, we build automations, as we go forward, what we're doing is we just keep globbing things on top of everything. We don't go back and try to refactor, try to make things better. We don't try to build composable, reusable artifacts that we can then share with the development teams to give them sample best practices. So when we go ahead and we're able to get this right, I can now look across an event lifecycle, across a task lifecycle, across the combination lifecycle, and I can start to measure beginning and ends. When I'm able to do this, I can now look at specific jobs in my automation and start to understand, where are my gaps? How can I optimize this? How can I make it faster? How do I make it better? So many of our customers, they're still struggling just to get the automation right. This is where they want to get to. They want to get to the point to be able to say, it takes me, so how many people here use t-shirt sizes when they measure their stories? Or use some story point mechanism? Can you say, let's use a t-shirt size. If I went ahead and I got a task right now inside your system and I say, this is a t-shirt size of medium, can you tell me exactly how many hours it will take for that developer to start and complete that task, and how long it'll take from completion of the task to getting it into production? Is that a repeatable process inside your organization? Anybody? Is that repeatable? Okay. So some people, it's great that you can do that. I've got probably 100 people in the room, I've got one. So 1% of this room can actually do that task. Oh, nope, it wasn't him, so sorry, we're back to 0%. So when we go ahead and we look at these task processes and we're trying to figure out how we can optimize them, this allows us to be able to create what we call inside of GitLab, we have flow metrics. So this gives us all of our DORA metrics, it gives us all of our value stream metrics, and we can start to calculate. You can even build custom dashboards. So you can group a bunch of microservices. You can build a report out of it. This is the thing that most business people are going to understand. They understand the reports. They would love inside their organization to say, I want to let you know every time that I've got a story point of medium, that this takes a developer 4 hours from beginning to end of task, and it takes us 2 weeks from the merge for us to get that into production. Man, now I'm building Oreos. I can create an Oreo, and whenever I have a bad Oreo in the process, I can take it off the line, I can go ahead and move it off to the side, but everything else can continue to be packaged and sent into production. Man, doesn't it sound like nirvana? Doesn't it sound like a place where we all want to get to? So to be able to do this, right now, this is what most of the people that I talk to have inside that are not using GitLab. This is what they end up with. So Jira has its data silo. Then they have a competing product that has their silo. And then they have change management, so ServiceNow has its silo. And then I've got my pipeline, my CI/CD, with all of its tools, has all of its data silos. So then what do? You know what, I can fix this. I'm going to purchase a really inexpensive solution called Snowflake. And what I'm going to do is I'm going to send all of my data into there, and it's going to go ahead and magically generate everything that I need. Unfortunately, it doesn't. What happens is you lose things like, well, what happened if the code review didn't have 2 reviewers and that's why the merge can't happen? You're not going to find that in just a bunch of dumped data. And if that's what's causing your flow metrics to be really out of whack against different projects, well, maybe you need to figure out, well, who's actually reviewing whose code? So what we want to get to is we want to get to a process where process management, developer experience, change management that we have automation, so CI/CD is still going from left to right, but our automation allows us to go either direction. So I saw a lot of hands go up when we were talking about deploying to Kubernetes. So one of the biggest issues that I've had from security teams is a lot of times there is there's sort of an area where when we define our Docker files, the Docker files are created by the platform engineering teams or by some other team. They're approved images that are then stored internally, and then a developer is allowed to add their deployment artifacts to that Docker image. But it is locked down. The developer can't change it. So now when we go ahead and we release that into Kubernetes, and the whole goal of Kubernetes was to allow us a small consumable artifact that we could update very frequently. But I'm seeing customers that Docker image is sitting in Kubernetes for days, weeks, months, quarters, sometimes even years. Well, what we end up finding out is somewhere inside the file system, there's a dependency that was added to that Docker image that now has a CVE. Whose responsibility is it to get that CVE repaired? So now I've got a new Docker base that needs to be created. I've got an in-flight image that's currently running in production. I've got a developer that needs to be notified that there's a new Docker image that they have to use for all future work. And I've got to make sure that that version that's sitting out in production, that I can go ahead and re-release a new version. Now imagine a process where I could automate from right to left. Okay, so I know what we did, which scripts we used, which manifests we used to go ahead and deploy it. So now I'll undeploy it. I will go back. I will now create and reopen the issue that automatically initiated the change. I will reopen the merge request with an appropriate branch process to go ahead and allow me to automatically map the new deployment process. I can do this underneath a hotfix. I can do this underneath a hotfix that will allow me to bypass a lot of the release orchestration, allow me just to do a new deploy right out of the gate. So most of our customers are wanting a solution now that allows you to not only automate from left to right, but also is allowing you to automate from right to left. This also needs to be able to plug in other third-party events so you can create a context-aware data fabric that is broken up in between metrics and analytics. So now I can store my telemetry data, I can store my logs, I can store information from my ServiceNows, from my Jiras. I can have all of this data, but it is centrally located where we can build context-aware reports. So now instead of me going off and having to create a Word doc for root cause analysis, you should be able to go in and hit a button that says, okay, where did we find the error? Let me click a button, use GenAI, go back through, look at the entire development release workflow, go ahead, determine who all the parties were that were involved, generate a doc, and then talk about what the remediation plan was and how you automatically deployed that and when it was resolved. Man, doesn't that sound like a great world? That's where GitLab, as we start to think about GenAI, we need to get GenAI into this process. This is where we consume so much of our time. We are looking at things like, what does this code do? What does this vulnerability mean? Do root cause analysis on your CI/CD pipelines when there's an error inside one of the jobs. That's where we're able to now amplify on the platform engineering side. We're able to amplify your skills to be able to say, I can now get you data that you didn't have readily available before. Because when we talk about code suggestions or Copilot or Tab9 or any of the other tools, it's great that we've got these tools that enhance that capability for developers, but we need to make sure that we also have similar capabilities for the platform engineers. So I've been a VP of operations in the past, and when I look at what's going on the code generation side, a lot of that stuff we used to pull from Stack Overflow, from other places that we would go ahead and search, we'd find code, we'd copy, paste it, put it in. So a lot of that stuff's relatively new. We had the same tools on the operations side. So we would go ahead and we'd go out and search and we'd find exceptions, things like that, and we would go ahead and resolve those as well. So this is just giving you that power of being able to solve a lot of your issues. But you can't do that without having that single data fabric. Because now I've got all of my exceptions, I've got all my logs, I've got all of my remediation plans. All of that data is inside of a single platform. So the best example for me to be able to talk about how we're able to do this in flight, I got to tell you, since I watched Drive to Survive on Netflix, huge F1 fan. Used to live in Mooresville, North Carolina, so home of NASCAR. Got to tell you, F1's where it's at. Now, if you've ever gone through and listened while they're driving, the telemetry data that they're able to capture off of a car with all of the sensors that are on that car, they're able to, at a split second, they're able to tell somebody if they need to pit or if it's an anomaly and they can continue driving. Now imagine a car traveling at 200 miles an hour. If there's something wrong with the car, lives are at stake. So right now, inside of the tools that we have, we need a way to be able to have all of that data at our fingertips. And we believe that there needs to be an open automation toolkit that you could plug in across any tool, just like we do in F1. All of these sensors, we should be able to have sensors everywhere inside of, whether it be an IoT device, whether it be a mainframe application, any of those things. But not only are we looking at the current running state in flight, but we're also looking at how we got that in flight. So they store data about which tires they pulled off the truck. So those kinds of things, we know that if I need a soft, medium, or hard tire, those are the kinds of things. Those are part of our software factory. That's part of the pieces beforehand. And then we have sensors on the car that tell us which tires are performing better while it's in flight. We need both sides of that data. So many of our customers really focus in just on what is going on in flight without looking at how all of the inputs that got to the point that allowed us to even get to that part. So when we start thinking about the data and how we can look at these flow metrics, I talk to customers, I'm like, look, no matter what solution you're using, you're gonna end up in a situation that you're gonna have data overload. You try to go down this process, you're gonna have so much data, you're not gonna know where to start. So there are actionable outcomes that you can actually create. So if you wanna crawl, you should be able to have your deployment frequency, you should have lead time for change failure rates, time to restore service, and monthly active users. And what's really interesting is I'll probably have a lot of people say, how many of you can do this? I'll probably get a lot of hands coming up. And they'll say, can you do this for 100% of your applications? And they'll see a lot of hands go down. So you'll have a number of applications that, especially when I'm doing this in a containerized world, deploying to Kubernetes, these things are easy. But if I tell you, hey, you've got a legacy BEA WebLogic or an IBM WebSphere running an ear that gets deployed to once a quarter, you don't have these metrics. So we've got to get a way to be able to get the metrics across all of the different applications. And then when you want to walk, you want to be able to start doing customer NPS scores. So a leader that I talked to last week, it was very interesting because he said that not only do they do NPS scoring of their external products, their public consumable products, but he feels like his team is a service to other people internally. So they do customer NPS scoring internally where they have internal customers, and they get rated. And that's how they get bonused, is based on their NPS scores. So if they're not providing a good service internally, they get dinged. They got to figure out, how do we get better? How do we make it better for our customers? And then you have your SLAs, SLIs, SLOs. Those are things where, again, on a project-by-project basis, how can I guarantee delivery of those services that I'm providing internally? And then cloud cost optimization. This is a really big one for a lot of our customers, especially with the current state of the economy. There's a lot of people that are like, oh, we'll just turn off some of the services. You can't just turn them off. You got to figure out how you optimize them. You got to figure out, can I run it in a smaller load? Can I run, like, had one customer where we talked about running EC2 images, and they were running 3 very large images to be able to scale the application. There were some small changes we could make to the application. We could actually scale it horizontally, and we could take that, and it was actually cheaper to run 6 smaller VMs than it was to run 3 of the larger VMs. So wouldn't it be nice to be able to have a set of tools that calculated that data for you and could show you, oh, by the way, if you moved it to a different topology, you could actually save $50,000 a month. Yeah, I'd love to have that data. And then for our customers that want to run, this is flow time. How long does it take? Going through, I love walking customers through this because we hear a lot of talk around Gen AI, and we talk about it's going to increase developer efficiency, increase developer productivity. So I go in and ask an executive, awesome. How do you measure productivity today? We don't. So how will you know what your ROI is? How will you know which developers is actually going to be most beneficial for? So when we go in and we talk to customers, we help them understand which teams would be best suited for being able to use Gen AI. I can tell you as a developer over 30 years, I mean, I have gone in, I've tested all of them, I turn them all off. I can use IntelliJ with their code suggestions and my key maps and everything else. I can type a lot faster than I can get code from Gen AI. But I've also been a developer for 30 years. Somebody who's new, somebody who's younger, somebody who's just getting started. Man, what a great learning tool. Having somebody who's sitting by your side being able to give you suggestions on better ways to be able to write your code. It's not something that we need to necessarily roll out up front enterprise-wide for everybody. But if I'm going to do it for the developers, then I better have a tool for the platform engineers or for the operations teams because they're going to get overwhelmed very quickly. Team health, flow velocity, there's a really great article. So when you want to start looking at developer productivity, there's a framework called SPACE. And it's an acronym, so S stands for something, P stands for something. Highly recommend you go out and look at it if you're looking at being able to do developer productivity engineering. It's a great way for you to be able to start figuring out how you want to start calculating those measurements. So all of these things, all these different metrics, again, are only capable when you're storing everything together inside a single data fabric, and you also have context awareness to know how you compare projects. So most of our customers want to be able to know how project A relates to project B, where we've got external staffing, how we can go ahead and optimize to know which external staffing team's doing really great, which ones are not doing so great, which ones do we think we're overpaying for. Those kinds of things are really valuable. But then at the same time, how are we doing from an industry perspective? So how does I work in banking, so how are other people in banking, what do their flow metrics look like? What does their velocity look like? Those things are really powerful. So with that, I hope that you've learned a little bit about how we can use automation and how we can start to, where we want to go as GitLab is our CI/CD framework. You can look at some of the epics. We're going to start expanding that to capture not only local events, but also public events, how you'll be able to use a single data store, how you'll be able to create custom value stream metrics, and being able to take that and be able to generate those reports internally for you to be able to meet your crawl, walk, run targets. So thank you very much, and I'll be around if anybody has any questions.